So after some consideration, I decided to make the inside radiuses for the molding. So I ground, and these guys are going to go in like this underneath the original sheet metal. You know, I've got this welded into the steel frame. It'll go underneath that original. Then I'm going to plug weld it down the steel frame to close out that. What I originally did was a window channel, right, for a roll-up, roll-down window back when I built the frame. So this will get plug welded in. I've got the other side kind of clamped on. And then what happened is a little bit of time passed. All right, I got the metal piece on. Same thing on this side. You can see it right in here. Welded it on there. I just basically plug welded, drilled 5/16 holes, about 1.5 inch spacing all the way down this, and then just plug welded it on. Come on. Sorry about the lighting. Yeah. Same thing on this side, plug welded it on, just took it down with a grinder. And close those out, ground everything, hit it with self-etching primer, and now it's ready for the trim. So on these pieces, you know, like they're similar to that, only these just screw in basically with sheet metal screws into the door. But as you notice, the holes get hobbered out. And I did experiment with that door. I welded up the holes, re-drilled them and all that, and it's very frustrating in the sense that you don't get great results anyway. So, you know, and that being that I, you know, ran a screw in, drilled, plug welded, and of course there's a little bit of fall through in the hole, re-drilled the hole, but then you got an uneven thickness within the material, and you go to screw a screw in and it drives to the side and all that kind of thing because there's more material on one side than the other as a result of the weld. And anyway, so basically I'm going to go with machine screws, oval head screws, you know, so they crown a little. They have the taper on the bottom, and run the whole thing in oval head screws down through weld nuts. In the case of the back though, because I got that 11 gauge tubing all the way around the door, around the frame, I'm going to drill and tap that. That's no problem at all. But then I can move forward. Now, for now, I'm just using these just tapered wood screws. What do you call them? Sacrificial, so that I can block all these out and finish them, you know, to get whatever I need to get into them. If I need to get a little minor material in them. I mean, there's the weld right there. It turned out good. I took my time on everything, but still, it is old metal. It does have some pits. It does have some damage. So I'll get them cleaned up and ready to go, and then I'll be moving on. I guess this weekend. I'll build that frame out. That's going to be part of the fabric is going to move in and down. I've really, you know, I can build the backer, which will probably be like a composite type wood, so that I can roll around and glue it and staple it and all that kind of thing, just like the door panels. But moving forward, oh glory days. Anyway, drilled and tapped. Had to make new holes up there, you know, for that radius, for there and for there. So everything's in, both sides. So, today is a Thursday for me, And I can start doing all this now. You know, doing all the, a little bit of filler, little bit of blocking. For that, I'll block with, you know, all kind of depends, but on what I got for a surface. But for the short areas, of course, I can use a barrel. You know, so I can hit it and define it. And that seems to work, that radius. It's touching everything, right? It's touching the entire surface. So something like that. I got a smaller one. You know, toilet paper roll is probably a little too weak. But to get that in there, it'd be a lot of finger work, you know, getting all these corners and stuff done. But for the most part, there isn't a lot of surface area. So, moving forward. Well, I got a wild hair, you know, as we were talking, we had the trim pieces on and all that, and then I kept looking over at that, and then I was looking at that, and then I was looking at that, and I'm going to just freaking do it. So I ordered another cheap plasma cutter. I don't know, I covered it a little bit in the series, but I've been using that cheap plasma cutter, but that's a high frequency. And I bought a laser etching table, and there's a gazillion of these on YouTube, you know, taking and converting these to plasma. Anyway, it worked, but it would work for moments, and as soon as it would arc, as soon as it would lift and strike, it would kick it out. I took out a laptop doing it, so, and I got a new laptop since then that I don't want to take out. So now I got a low frequency, or a non-high frequency is what they call it, and still 50 amp, but this is a pilot arc, so we can strike an arc in the air and all that kind of thing. And then I went and bought some extruded aluminum, because this is like a 16-inch by 16-inch table, and it was, my intended purpose was to get it to work and then expand it to this 2 foot by 3 foot, because that's what fits in my shop, and that covers 90% of the, you know, brackets and stuff that you want to cut out. It's not going to cut a long piece into what do I want? What am I trying to say? It's not going to cut a long piece in the sense of a long chassis piece or anything like that, but it certainly will do a significant amount of parts cutting. So I bought the extruded aluminum, drilled it, tapped it, you know, drilled it out, put my reliefs in for the threaded bolts, all that kind of stuff. And now I'm just in the process of assembling it, and decided to stop and do a quick video on that. Sometimes you need a break from what you're doing so you don't get so sick of it, right? So that's today's little epic, and I'll keep you posted on my progress. All right, well, we're digging our way through here. This is the original extrusion. It's probably not easy to pick up on video, but it's tapered on the top to guide the wheel. You can see the taper on the wheel. And the taper on this is much more gentle. So this is one of the cut-off scrap pieces. But I set up the mill in a chamfer with the same angle, in this case 45 degrees, but I mean with the same angle, and now I'm running it down the mill. I got this one done for the center track, and it actually worked out very, very nicely. So I just don't want to lose it. But now I have to do the top and bottom of the side rails, so I'll tear it apart and chuck those up in the mill and run down them. That was a strong day, but I had to spend hours just lengthening the harness so that it would go the distance, right? And travel, you know, in both axes. So X goes full, Y. I got plenty of cable for Y. So now it's time to rig up the torch, wire up my trigger for the torch, and give her a test drive. Hey guys, look at that fancy drawing I did. That's just basically some swirls and stuff to try to find if I can get the laser to do it. It's just a JPEG. It's just me scribbling. Okay, and as it turns out, it loaded it. And this is laser Gerbil. It came with the Two Trees table, so it's cutting it like a laser. And the line width, the way it imported it, the line width is wider. So what it's basically doing is it's cutting, moving up on the Y plane. Got my peanuts. Moving up on the Y plane slowly, and then traversing X to make the widths of those lines. So obviously that type of programming won't work for a laser, but it's a nice long run that's giving me an opportunity to see if I have any interference. So while it was running, and before I loaded the program, I put fender washers in. I don't even know if I covered this. I got a drain pan in. Okay. Welded in. You see all my grind marks, but welded in a bung. Right there. With a plug. Then I screwed it to the original frame. I wanted it to fit between these rails, so it's a little shallower than the table, but that's okay because I can't get outside of this frame. Hindsight's 20/20. I mean, if I would have put these posts on the outside of the frame and put a pad out there, I'd get more use of the frame, you know, the full 24 by 36. Right now it's, because of all it indexes, I'm at 17 by 27.5. But I'm happy with it. It can't go all the way up to the edge because it would hit. See, so that's what the torch will do. I finished making a torch mount. This was on my other table when I was originally experimenting with a high frequency and couldn't get it to work. But I just found a couple of points to keep it, and it's just working spectacular. So with the pan and the side shields, then finally I put these front shields on. This one I kept up high because I want to protect remember the torch is way down in here on top of the table. So he's got to climb 5 inches, you know, to land on there. And then I bent the inside so it deflects things back to the pan. You know, it lines up with the pan, but there is a gap under there. Because of where the torch is at, it could probably cut in this area. If I stay, you know, even an inch up, then I'd be a little safer there. I need to think about that further. And then on this side, I dropped this 5-inch piece down flush with, almost flush. I mean, it's up about 1/8 of an inch with the surface. It's actually flush with these. And then you can see the gap down there, but he's bent way in. And again, this is going to come to here. So the torch will never see that side, but the torch is hanging out front of here, so it can see this side. But in any event, now I've got the table kind of, got the deflectors on, spark deflectors, got the water table on. Haven't checked it for leaks. I'll just fill it with water and mark them with a Sharpie, and then, you know, if I have to fix it, fix it. But all I had to do on this was weld the corners, and I welded the inside and the outside and the bung. Once I had the bung on, I wiped some RTV on it, so that'll cure for 24 hours. I doubt that's going to leak. So it's a 1-inch pipe that steps down to a 1/2-inch pipe, female to female, and so I can get large debris to fall through that 1/2-inch pipe thread. And so that's kind of where it's at right now. I'm getting ready to get a platform under here to put the plasma table on, or the plasma torch on, and then start doing the connections. So fingers crossed, but it's going pretty good. Well, it's still cutting. You see the blue dot? I'm almost past that circle, but I am past halfway. So basically what I've been doing is I'm going to let it go all the way. And the nice thing about it moving slow, cutting like a laser would, of course, but plasma is going to follow the lines, but is that I'm only incrementing and moving very, 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 very small steps all the way up. So if there's going to be bind, I'll find it. You know, whether it's in the rails, the machining of the rails, the cabling, so on and so forth. Thus far, it's been well over an hour. Thus far, no interruptions. And, you know, I built these splash shields with it running. I just finished grabbing a couple pieces of angle and building the floor. Or shearing a piece of aluminum, screwing it down in 4 sides. So then I can set this up, got a ground clamp location, and then I can start setting this up and wiring up the torch. But when you think about it, the only thing that torch is going to do is turn on and off now. It's just a matter of whether there's any interference, whether my clearance is changing, you know, and I can full adjustability with washers if I do have impact. And of course that's adjustable for material thickness up and down. This isn't wiggling or wobbling. So my double clamp setup is working. The torch, of course, I haven't used it since I modified it. So I'll have to see if I have a leak, but I mean, I very much doubt it. I Loctited that back together. Boy, other than that, it's oh, will this hold water? Will this hold water? You know, when I get to that point, I'm going to hold water. So I'm going to move on to other things. I got a customer project here, and the guy's got a Cadillac that he bagged, just sitting upside down. He bagged, the weld work on the bag pads is fine. It's just, it appears to be the reason why he wanted to make sure the mounts were on tight and right. And the other thing is getting the angle and all that. So with this rear end, I'll copy the plane, you know, the angle, and mount the 1, 2, 3, 4, 5, 6 brackets at that spacing onto the 9-inch Ford housing. So it's not a huge job. It's a relatively simple job, but I'll get that wrapped up here today too. So, but probably move on to that, and then kind of come back to this and go back and forth. All right. The blue line is supposed to be travel, and I'm just cutting a little square out. This is 10 gauge material. I got my laser wired up. I had to build a little relay to grab the trigger. I have actually a couple are coming in, but I'm using a couple pieces of wire right now. Like 42 amps. Probably a little heavy for 10 gauge, but let's give it a try. So we'll push. Go. We'll push. Go. Oh, cut might be out of bounds. Cut anyway. I wasn't supposed to do that. but that's okay. So I got to make sure that's a travel layer, not a cut layer. That's interesting. I'm learning. All right, so I did get the plasma table going. I played with settings and to try to dial it in, and I got it dialed in. I'm less than a half a millimeter out, whatever, 18 thou, and I can dial it in even more. I'm just in this case I was working on with 10 gauge, making little squares. And the setup is just a 10 millimeter hole in a 20 millimeter box, and just burning it in to dial it in. You can see on this first one I got a really good heat signature, and then I started dialing it back. You can see a little bit of a heat signature on there. And this one, this was the last one. I got no heat signature, some nice flush edges. This one I had a little mistake on, but I bumped the head onto the end of the table. I wasn't properly positioned. So I'm continuing with that, but I got a relay board tied into there. That relay switches with a signal for the torch. It flicks the relay on, which basically does this trigger, but this trigger isn't wired in. I'm taking that relay board and wiring direct. So you can see laying down there is the actual torch trigger wire, and it works great. I'm getting ready for work, but I will get a video of this down the road. So then back to the car. At this point I'm monkeying around with the weather seal, piece of cardboard, to try to see how well the fitment is. I had a high spot, and I tapped him down, so now I got, you know, that going for me. But anyway, I'm basically trying to get that kind of laid in, get a visual. It's just wedged with cardboard underneath here, pushing down. I want to make this top piece. So at this point, I'm going to start building out that profile. I did a sketch, and basically it's going to be a radius from the top view, 42.5 inches wide, but it's going to stand out to 5 inches in the middle and go to near zero. It's going to go to about 3/8 of an inch in all actuality, but when I get the fitment up, I'll dial that in. From a side view then, it's going to come up, come down. I don't know if I'm going to go with a tighter roll here. That's just an option. And then I'm going to come back. So it'll be 4 inches on this leg, 5 inches, this is the top, and then 5 inches tall. And then I got, you know, from the front then, the bow in the roof is 5 inches in the center, 4.5 in the sides. So all I'm working on at this moment is I'm going to take one piece, go 3/4 of an inch. I don't need that much material there, but 3/4 of an inch, come down, bend it, go 3/4 of an inch on the leg, and then establish this shape first. And I'll just use the shrinker, try to build out that shape. Then after that's complete, then I'll have to cut into each end to build the radius for that 1/2 inch that needs to come out. I'll build that radius in there, then I'll dry fit it, then I'll come back and I'll build this bottom leg. I'll butt weld that on. This will be cut and butt welded. So it's a compound curve, but I believe I can get her established. So in looking at it, you can see the bows. They have a very gentle radius, and that'll finish off at the top just behind the wiper motor. Which is down considerably from the roof. But the bottom will be straight as it follows the window channel. Then on each side, you see it turn in radius. I probably will build that into that top header so that my trim pieces for the side will just be straight, formed pieces. That's kind of where I'm at, and that's kind of what I'm planning on doing. Later.